Welcome back to G Fun Facts Online. Today we are diving deep into deep space, specifically into a discovery that has shaken the foundations of astrophysics. We are talking about the red monsters. These are three specific galaxies found by the James Webb Space Telescope, or JWST, that simply should not exist. To understand why these objects are causing what astronomers are calling a good crisis, we have to strip away what we thought we knew about the early universe. For decades, the standard model of cosmology gave us a very specific script for how the universe began. It was supposed to be a slow burn. The story went that after the Big Bang, gravity slowly pulled together chaotic clouds of gas. These clouds were small, messy, and inefficient. Over billions of years, they would gently merge to form the majestic spiral and elliptical galaxies we see today. This was the hierarchy. Small things become big things over a long time. Before JWST launched in late 2021, our view of this era was defined by the Hubble Space Telescope. Hubble is a legend, but it sees primarily in visible and ultraviolet light. When Hubble looked back at the first billion years of the universe, it saw what we call the blue nuance population. These were tiny, primitive scraps of galaxies. They looked like train wrecks or messy blobs. They were blue because they were forming young, hot stars, and crucially, they appeared to have very little dust. The standard theory explained this perfectly. It said that star formation is a chaotic, inefficient process. As gas clouds collapse to form stars, those new stars blast out radiation and supernova winds that push away the remaining gas. This is called a feedback loop. It chokes off future star formation. It meant that galaxies grew slowly, converting only about 10 to 20% of their gas into stars. That was the comfortable, standard model. But then, the James Webb Space Telescope opened its golden eye and found the red monsters. This discovery wasn't an accident. It came from a brilliant observational program called FRESCO, led by researchers at the University of Geneva. Now, usually, astronomers find distant galaxies using photometry, which is basically taking pictures through different color filters. If a galaxy looks bright in infrared but invisible in blue light, it might be distant. But photometry is tricky. A galaxy might look red because it is far away, or simply because it is old and dusty. You can never be 100% sure without a spectrum, which is the chemical fingerprint of the light. The FRESCO program did something unprecedented. They used JWST's near-infrared camera in a mode called grism spectroscopy. A grism is a combination of a grating and a prism. It splits the light from every single object in the field of view into a spectrum. This allowed the team to analyze light from thousands of galaxies simultaneously. They weren't just looking for shapes. They were looking for emission lines, the signatures of glowing hydrogen and oxygen gas. In this data, the team noticed three specific sources. In standard Hubble images, these spots were invisible. They were ghosts hidden in the dark. But in JWST's infrared eyes, they roared with intensity. These galaxies are located roughly 12.8 billion light-years away. That means they formed when the universe was less than a billion years old, roughly 5 to 7% of its current age. When the team calculated their masses, they were stunned. These weren't the tiny blue nuance blobs we expected. They were monsters. Each one packed a stellar mass roughly equivalent to 100 billion suns. That is comparable to our modern Milky Way, but existing at a time when the universe was in its infancy. Finding one would be an anomaly. Finding three in a small patch of sky poses a massive puzzle. So what exactly is a red monster? It comes down to three key factors: mass, dust, and efficiency. The red in their name comes from the fact that they are swimming in cosmic dust. In the early universe, dust, which is made of tiny grains of carbon and silicon, was thought to be rare because it comes from dying stars, and we thought there hadn't been enough time for many stars to live and die. The blue nuance galaxies looked blue because they lacked this dust. The red monsters, however, are incredibly dusty. This dust absorbs the blue ultraviolet light from their young stars and re-radiates it as a warm infrared glow. To Hubble, they are invisible walls of black smoke. To JWST, which sees infrared, they shine like beacons. This tells us they have already lived fast and furious lives, enriching their environments with heavy elements much faster than predicted. But the real crisis is the efficiency. In a typical galaxy like the Milky Way, or even the early blue nuance galaxies, star formation is wasteful. For every 100 units of gas a galaxy pulls in, only about 20 turn into stars. The rest is blown away. The red monsters, however, are operating at near-perfect efficiency. The data suggests they are converting nearly 80% of their baryons, or normal matter, into stars. This is a staggering number. It implies these galaxies are feedback-free zones. Stars are forming so rapidly and densely that the usual mechanisms that shut down star formation, like supernova explosions, haven't kicked in or are being overwhelmed. So how do you build a monster like this? Theorists are now scrambling to explain it. The leading theory is the feedback-free starburst. In the modern universe, when a massive star forms, it emits intense radiation and eventually explodes, pushing gas away. That is the safety valve. But if a gas cloud in the early universe was dense enough, it might collapse faster than the stars can push back. Imagine a cloud of gas collapsing so catastrophically fast that millions of stars ignite almost simultaneously. By the time the first supernova goes off, 80% of the gas has already locked itself into stars. The safety valve is stuck, and the galaxy gorges itself on gas, reaching massive sizes in a fraction of the usual time. Another possibility is what we call a top-heavy initial mass function. In our local universe, for every massive star, thousands of tiny red dwarfs form. But if the early universe was top-heavy, meaning it formed significantly more giant stars than dwarf stars, these galaxies would produce much more light and heavy elements per unit of mass. This would make them look more massive and evolved than they actually are. They might be imposters made of giants. Now, it is important to distinguish the red monsters from another recent JWST mystery called the little red dots. While both appear red, the little red dots are compact, point-like sources, likely supermassive black holes or quasars shrouded in dust. The red monsters are different. They are extended, massive galaxies where the light comes primarily from billions of stars. They are likely the ancestors of the massive elliptical galaxies we see today. This discovery doesn't break the Big Bang, but it creates a severe tension in our timeline. It suggests that galaxy growth is not always a slow march. It can be explosive. The early universe was likely bursty, characterized by violent episodes of highly efficient star formation that we simply do not see today. It also challenges our understanding of the dust budget. If supernovae are the main source of dust, these galaxies must have had an incredible rate of supernovae explosions very early on. So what is next? Astronomers are planning to turn the ALMA radio telescope toward these coordinates. ALMA can see the coal dust and gas directly. If it confirms the gas masses are low, because it was all turned into stars, it will confirm the high-efficiency theory. We are also waiting for future surveys to find even rarer, more massive monsters. Is there a red titan out there? We do not know yet. What we do know is that the universe is not the orderly, slow-moving place we thought it was. The discovery of the red monsters has painted a new picture of the cosmic dawn as a time of chaotic, rapid, and violently efficient creation. We used to look for the blue nuance, the delicate proto-galaxies. Now we know we were missing the giants lurking in the smoke. The script of cosmic history is being rewritten, and thanks to the red monsters, the first chapter is turning out to be a thriller. That is all for this episode of G Fun Facts Online. Thanks for listening.